The world today feels tense. Ongoing wars between nations, rising military confrontations, and strong statements by world leaders have once again brought a dangerous word back into global conversation: nuclear. Warnings about escalation, deterrence, and retaliation appear frequently in headlines. Even when no weapon is launched, nuclear capability silently influences diplomacy, energy policy, and the global balance of power. Yet there is a powerful paradox at the center of this fear. The same nuclear science that threatens destruction is also one of humanity's most advanced sources of energy and progress. The shocking truth is this: a nuclear weapon and a nuclear power plant are built on the same science, and the only real difference is how that power is controlled. At the core of nuclear energy lies the atom. Inside the nucleus of an atom, an enormous amount of energy is held together by nuclear forces. When this energy is released in a controlled way, it becomes nuclear power. Unlike fossil fuels, nuclear energy does not come from burning material. Instead, it comes from changes within the nucleus itself, where a small amount of mass is converted into a large amount of energy, exactly as described by Albert Einstein's equation, E equals mc squared. The most widely used nuclear process today is nuclear fission. In nuclear fission, a heavy atom such as uranium-235 absorbs a neutron and becomes unstable. This instability causes the atom to split into two smaller nuclei. When the atom splits, a tremendous amount of heat energy is released, along with additional neutrons, creating a controlled chain reaction. Inside a nuclear reactor, this reaction is carefully regulated using control rods and moderators. The heat produced turns water into steam, the steam spins turbines, and the turbines generate electricity. This process produces large amounts of power from a very small quantity of fuel and releases almost no carbon dioxide during operation. Now imagine if humanity could harness the same reaction that powers the sun, without explosions, without meltdown, and without long-lasting radioactive waste. This brings us to nuclear fusion. Fusion is the process in which two light atomic nuclei, usually isotopes of hydrogen, combine to form a heavier nucleus. When fusion occurs, an enormous amount of energy is released. Fusion does not split atoms, it joins them together. It produces far more energy than fission, creates minimal long-lived radioactive waste, and carries no risk of an uncontrolled chain reaction. However, fusion requires temperatures hotter than the sun's core and extreme pressure, making it one of the greatest engineering challenges in human history. In recent years, major breakthroughs have been reported, including significant advances in Chinese fusion technology, where experimental reactors have crossed previous limits by sustaining plasma for longer durations and achieving more stable confinement. These developments suggest that fusion is moving closer to practical reality. Today, humanity stands between two nuclear futures. Fission powers our present world, while fusion represents a cleaner and more abundant future. The atom itself is neutral, and whether nuclear energy becomes a force for destruction or progress depends entirely on human responsibility. For more informative science videos like this, please like, share, follow, and subscribe to the channel.